When building a wheel, it's important to use the right spoke length. Here's how to do that. Calculating spoke length can be boiled down to this formula. We need 3 key measurements: flange diameter, center-to-flange, effective rim diameter. Most wheels will need values for both right and left sides of the hub. For simplicity, we will focus on the drive side. The flange diameter is measured from the center of a hole to center of its opposite hole. Pro tip: align caliper jaws on the edges of these holes. Same distance, easier to measure. CTF is difficult to get directly. We need something simple to measure. First, get a center line by dividing over locknut dimension in half. This defines one edge of CTF. Because calipers can't be accurately placed on the center line, we measure what we can, from the locknut end to the center of the flange. Subtract this distance we've measured from the center line. The result is the center-to-flange value. For this example, 22.5 millimeters. Now for the effective rim diameter, ERD. This is the distance between nipple slots on opposite spokes, essentially where you want the spokes to end. Measuring straight across the rim is the nipple seat diameter. This nipple seat diameter isn't the ERD, but it is what we can physically measure. Ideal spoke lengths allow the spoke thread to fully engage with the nipple. ERD accounts for this by adding the nipple height. This can be measured with calipers and is at times provided by manufacturers. In this example, we have 1.5 millimeter nipple height. Using the calipered ERD can be measured directly. Place the calibration tube between the feelers. Use the adjustable window to add twice the nipple height. This gives a one-shot ERD that's fast, precise, and repeatable. 587 millimeters. These measurements provide values for our spoke length formula. To solve for spoke length, let's plug in ERD for this velocity rim and nipples, 587 millimeters. Next, plug in the flange diameter value. For our example Onyx hub, this was 50 millimeters. Last, drop in the center-to-flange, 22.5 millimeters. X represents the 32-hole 3-cross pattern in our example. Y is for variations in hole diameter. We'll use a fixed value of 2.5 millimeters. With these values in the formula, we see an ideal spoke length of 285 millimeters. Now for something new. How crucial is each measurement to the process? By simulating inaccuracies, watch how incorrect values impact the spoke length. If CTF is off by 4 millimeters, which is a significant error in measurement, we find that our spoke length is off by only 0.3 of a millimeter. That's unlikely to cause a critical error. If flange diameter is off by 4 millimeters, another serious measurement error, our resulting spoke length changes just over half a millimeter. While this is an important measurement, such an error is unlikely to cause a wheel building failure from spoke calculation. If ERD is off by 4 millimeters, spoke length is off by 2 entire millimeters. That's significant and could fail the wheel build, wasting time and resources. 2 millimeters too long risks the spoke thread bottoming out on the nipple. 2 millimeters short leaves threads exposed, risking broken nipples or the wheel not lacing up at all. Effective rim diameter is the single most important measurement in the spoke calculation process. The best way to get it right is to measure directly. To learn more about calipered, visit monolith.tools.